Hey guys, today I want to introduce you to the idea of angles being measured in degrees and in radians, and some of the vocabulary and stuff that's required as we start a new unit of trigonometry. First off, what does it mean to have an angle? So you saw a couple angles on that previous slide. An angle is the amount of rotation between two different rays, and we call those rays the initial ray and the terminal ray, and an angle. This angle I have drawn in what we call the standard position. Standard position is when you have the initial ray pointed along the x-axis. And when you do that, then how much this has rotated, if you rotate it around, you can actually see it being measured in degrees. And so this is 90 degrees. You can keep going to 180, and down here would be 270. And a full rotation all the way around becomes 360. And then my program's going to restart, but mathematically we would continue to bigger and bigger numbers. This would be like 400. This would be 450 degrees. This is now 540 degrees all the way around. And so anyway, that's that. If you rotate in this direction, we call that positive rotation. If you go backwards, we call that negative rotation. So it has positive rotation when you rotate things counterclockwise. Once again, the x and y axis, they divide the rotational quadrant. The x and the y axis here then divide the coordinate plane up into 4 quadrants. And those quadrants you've probably heard of before are abbreviated with Roman numerals, I, double I, triple I, and IV. And the reason they are in that particular order is because as you rotate around, the first quadrant you rotate through is quadrant 1, and then quadrant 2, and so on. All right, let's look at a couple examples. Why don't we try to draw a couple of these angles and state what quadrant they're in. So to do that, here is a coordinate plane, and I will rotate this around 210 degrees. So it's important to note that each quadrant is 90 degrees. So here's 90, and here's 180, and if I go a little bit further, somewhere around in here is about 210. So there's 210, and specifically this would be in quadrant 3. If we wanted to draw negative 45 degrees, we would rotate, instead of up and over, we would rotate down. And negative 45 degrees is about here. And that's definitely in quadrant 1, 2, 3, 4, or IV. To do 510 degrees, 510 is a lot. In fact, it's more than a full circle all the way around. And so definitely have to keep track here a second. We've got 90 and 180 and 270 and 360. If I continue, the next 90 would bring me to 450. The next 90 after that would bring me to 540. And so 510 is somewhere in here. That's definitely in quadrant 2, even though it might think like 1, 2, 3, 4, 5, 6. We don't start counting beyond 4. So this is definitely still in quadrant 2. Why don't you hit pause a second, see if you can draw the remaining 3, and then check back with me in a second. So after taking a moment and graphing those, found that negative 120 is down here in quadrant 3, 400 is in quadrant I, and 350 is in quadrant 4. Now, really wanted to take a closer look at this 510 one that we had done before the break. That is similar to an angle like more than 90 and 180. It's like 100, and in fact, I can figure out, I could draw this more perfectly if I knew exactly how far this needed to be. That concept that this angle of 510 and what really is 120 degrees, those are, excuse me, not 120, 150. those angles, 150 and 510, have a relationship. Those angles are called coterminal angles. So two angles that kind of end up in the same location are called coterminal. They're not equal per se, but they certainly share a bunch of features, not to mention they look the same when you graph them. And you can always find other angles that are coterminal to a given angle by either adding or subtracting full rotations, 360. That's how I was able to figure out where I needed that angle to be. 510, if I subtract 360 from it, was 150. I did that subtraction wrong the first time. That's why I said 120, right? So here's a couple examples. Find some other angles that are coterminal to each of these. And so to do that sort of thing, all I would do is take the angle they gave me and either add or subtract 360 from it. So negative 60 degrees, if you wanted to picture that a moment, negative 60 degrees is down here. And in fact, there, it's at exactly 300 is where negative 60 is coterminal to. And how you could have calculated that without drawing it and having the protractor pop up would be to add 360 to it. If you add 360 to negative 60, you get 300 degrees. If you add another 360 to this, you get 660 degrees. And that would be the angle that is drawn here. Once around to 360, here's 450, and 540, and 630, and then 30 degrees more would bring me to 660, which is in that same location as all the others. So 495 is one that's all the way around, like more than I could, more than my protractor will go, right? It only goes up to 360. And so 495 is somewhere in here. If I wanted to know where I should be to draw that exactly, I should subtract 360 from this and see what I get. So 495 minus 360 is 135. And so 495 and 135 are the same angle. If I were to subtract another 360, I get negative 225. And so all of these angles are represented in the same location, about where this orange cursor is. So why don't you hit pause a moment and see if you can come up with a couple other coterminal angles for a negative 100 and 575. So I wanted to introduce you now to another way that you can measure the amount of rotation, which is more convenient if you're talking about how much something has, say how far something has rolled, and you wanted to compare that to the size of the circle that's rolling. A radian is a unit of measure that's shown right here, and a radian is defined by if you were to walk around the outside of a circle exactly one radius in distance, that amount is called a radian. And so I wanted to show you a moment some radians a little bit. So I wanted to show you some radians a moment. If I rotate around, as soon as I've rotated around the distance, this is close, of one of these orange radii around the outside, I'll have reached 1 radian. So this purple amount of angle is 1 radian. Of course, you could keep going. If I keep going, here's now an angle that's 2 radians. And here's an angle that's 3 radians. And if I were to go all the way around, it's like a little bit more than 3 point something. And I hope some of you guys that triggered in your head, wait a minute, 3 point something. I know a number that's that. Pi, exactly pi, 3.14159 and all the other digits that go along with it. That is exactly 1 half turn. And if I were to keep going, here's 4 radians and 5, 6 radians, and a full circle is about 6.28, or exactly 2 pi radians. Because halfway around is a radian, angles in radians are almost always written as fractions, specifically as fractions of pi. And so here's a couple examples. This angle right here, this angle from here to here, that is called 2/3 pi radians. And so an important skill that you might need to see is just to think about what's meant by an angle like 3 pi fourths. And how do we draw that? And so today at lunch, I made a quesadilla and I cut it up into a 3 pi fourths radians. And so to do that, first thing you got to do is find and cut it in half, because that's pi radians. And then I split this up into 4 equal pieces and I cut out 3/4 of it. So there is 3/4 pi radians. Now, you probably aren't going to want to make a quesadilla every single time you need an angle drawn. And so let's think about how we can draw this 3 pi fourths idea. And here are some steps. If you have to draw an angle in radians, that's some sort of fraction of radians, start by taking a half plane. Remember, that's the top half of the little quesadilla, right? I cut it in half. And split that up into whatever the denominator is, equal pieces. And so I cut it up into 4 equal pieces. And then you count out the numerator, that many of them, 3. So if I were going to do 3 pi fourths, it would look something like this. Here is plane, and I'm going to look at just the top half of that a moment, and I'm going to try to split that up into 4 equal pieces. And so to do that, I'll probably start by cutting it in half. And then maybe I'll cut each half in half. So that would give me fourths, right? So here are fourths of pi. And then, oh, I had one extra. And then I would start at 0 and I would count out 3/4 of them. So here's 1/4 and 2/4 and 3/4. So with some practice, you can get really good and fast at it without taking a whole lot of time, and it's really accurate. If I were to just draw an angle of, say, 135 degrees, I'd be guessing without a protractor. But if I have to draw 3 pi fourths, that's not too bad if you draw a few little guiding lines like that. Sometimes you might have to go beyond 3 pi fourths. If I had, say, 5 pi fourths, then I would continue to rotate around. Here's 4 pi fourths, and then 5 pi fourths would be down here. And if you needed to extend these guidelines into the opposite quadrant, you could totally do that, right? So that's how you can draw angles and radians. So let's look at a couple examples. So if I wanted to draw 7 pi sixths, then the first thing I would do is take a coordinate plane and look at the top half and cut it up into 6 equal pieces, which I'd probably do by cutting it in half and then cutting each half up into 3s. And now that I've got it measured in sixths, I'll take an angle and I'll just count out 7 of them. So here's 1/6, 2, 3, 4, 5, 6 sixths, and I'd have to extend into quadrant 2 down here. So there's 7 pi sixths. That's definitely a quadrant, quadrant 3 angle, isn't it? Let's try -3 pi eighths a moment. So if we take coordinate plane and split it up into 8 equal pieces, which I'd probably do by cutting it in half, then cutting each half into halves, which are quarters, and each of those quarters into eighths. So there's 8. Now what I'll do is measure around and count out 3 of them. So 1, 2, 3. Oh no, this one says -3 pi eighths. All right, so that means instead of going up 3, I'd have to go down 3 of them. And so that would definitely put us down here into quadrant 4. So why don't you guys hit pause a moment and see if you can draw the remaining 2 a second. You gonna go?
Yep.
Not gonna help me anymore? All right, I love you. See ya.
See ya.
All right, I hope you were able to find 7 pi tenths over here in quadrant 2, and 2 pi thirds is almost the same thing. This is just a little bit more than 2 pi thirds, but anyhow. Last skill we need to be able to do is to be able to convert back and forth between degrees and radians, because degrees is probably more popular, more familiar to us, but radians is definitely a helpful one to be able to measure in terms of the amount of rotation and fractions of that. So to be able to convert back and forth between the two of them requires a conversion factor. You need to memorize that pi radians is 180 degrees. Or that 2 pi radians is a full circle is 360 degrees. Anyhow, if you can remember that, then you'll know that to go back and forth between radians and degrees is a matter of either dividing by pi and multiplying by 180, or if you're going the other direction, dividing by 180 and multiplying by pi. So let's look at a couple of different examples to end our video today. Let's start by trying to convert 110 degrees into radians. And so to do that, the first thing I'm going to do is write 110 degrees. And I want to divide that by 180 and then multiply it by pi. And so to divide by 180, I'll simply write it as divided by 180. And then to multiply by pi, I'm not going to actually use a calculator and multiply by pi. I'm just going to write pi at the end of this. And this is a fraction that's equivalent to 110 degrees written in radians. The only thing we would still do maybe is to reduce it. And so if you want to reduce this by hand, you might notice, hey, they're each divisible by 10. And that would give us 11 pi on top and 18 on the bottom. If you wanted to use a calculator to do this sort of thing, you could do 110 divided by 180, and then don't actually type times pi, but just hit enter and you'll get a decimal number. And then if you hit the math and convert to fraction button, it'll write it as the reduced fraction for you, 11/18. And then just throw the pi on at the end when you multiply by pi. So here is 110 degrees in terms of radians. It's 11 pi 18ths. Let's look at 320 degrees a moment. So 320 degrees. Again, we'll divide that by 180, and I'll do that on the calculator a moment. 320 divided by 180, and hit math, convert to fraction. I got 16 ninths, so 16 ninths, and then don't forget to multiply by pi, which means write pi on top, right? So there is 320 degrees in terms of radians. If you need to convert the other direction, so here's 2 pi thirds, and you want to figure out how many degrees that is. So to do that, we will start by dividing by pi, and dividing by pi simply means not writing it anymore, right? If we divide by pi, it's gone, and then we need to multiply by 180. So 2 times 180 is 360. 360 divided by 3 is, I think, 120. I would encourage you to try to hit pause a moment and see if you can convert the remaining ones into whatever unit's not given to you. There, hope you were able to find that 90 degrees is pi halves. This negative pi over 90, it's the same thing as negative 20 degrees. 135 is 3 pi fourths. 360 is 2 pi. And in fact, that fact right there is probably an important one that you ought to try to commit to memory. The hardest one I thought that was still here was negative 5 pi twelfths. And so just real quick, how do we do that one? I'll write negative 5 pi twelfths on top. And I'll divide by pi, which means we no longer have the pi in there anymore. And multiply this by 180. And definitely I'm using a calculator for this sort of thing. So negative 5 times 180 was negative 900 on top, and negative 900 divides by 12 nicely into negative 75. So final answer there, negative 75 degrees. Hope you're able to get started with some of the ideas between degrees and radians. Be sure to catch the next video, which is about reference angles, kind of an important idea, especially when solving equations in a little bit. And we'll catch you later.